statistical statement, right? All right. So you tell me what I need to put for the APA style statistical statement, and I will write it on the board. I already figured out that children will read significantly longer if the story they're reading has their name in it than if it doesn't have their name in it. Figured that out. Now I need some APA. What should I write?
T.
Huh? T. T, good. Go with your strength. Go with it. He's like, T. Yes.
Parentheses 10.
Parentheses 10. 10?
5.
We would use 5 this time because we use the degrees of freedom. You're looking at a different one. You're looking at independent groups. We're talking about related groups. We need this. Well, we did, the one, that's what we're talking about now. This is from independent groups. We're talking about this is all. We're trying to figure out this. So, we used 10 when we did independent samples because we had pooled degrees of freedom, right? We had to consider the fact that we had 2 samples. Each sample had 6 members. Each sample had a degrees of freedom 5. We had to pool the degrees of freedom to get 10. So for independent samples, you're absolutely right. But this is related samples. We've got one group of kids. We're testing them twice. So our scores for the modified book and the scores for the ordinary book are related to each other because they came from the same group of kids. Right? So this time we're talking about the one that goes in this box now is going to be degrees of freedom for the different scores. And what's that? What was our degrees of freedom for the different scores?
5.
5. Because there were 6 different scores, and if we do degrees of freedom for that sample of scores, n minus 1, we get 5. Now what? Equals. Now what? Huh? We need a value here first, not p. We need a observed. We need a value for t observed. 2.62. Positive 2.62. Remember, we always mark the polarity to indicate which tail we found the result in. And that's going to matter when you guys start doing problem sets and practice problems, because sometimes you're doing 2-tail tests, so you have to make sure that that's clear. Okay, so we've got 2.62. What's next? We need a comma. P. All right. Less than what? 0.05, because that's our alpha. Right. So here we're doing probability and alpha. Okay, probability relative to alpha. Okay, so the probability of getting this score given these degrees of freedom is less than 0.05. Okay, what's next? Comma. One tail. Okay. What's next? Comma. D equals, we can do either form of effect size. D equals, what did D equal?
1.07.
1.07. Okay. And if we had done R squared? 0.58 or 58%. You could write it either way. Technically it's supposed to be this, but lots of people write 0.58 anyway. Now, you're going to want to practice your independent samples and related samples t-tests, because that's what the next exam is all about. There are links to online sites that have practice problems posted. The problem set is also posted for you. You need to work on that over the weekend because we're going to be talking about that in class on Tuesday. And then in lab on Tuesday, you guys are going to be doing a review where you get more problems to do. If you'd like to get a head start on those problems, the handout that you're going to be given in lab is posted already in the lab materials folder. So 6 new problems you've never seen before. Some two-tailed, mixed up, some independent groups, some related groups, and they are not labeled which is which. You have to be able to tell from reading the summary which kind of test you should do. So if you want lots of practice this weekend on t-test so you're ready to go for that test, which is 1 week from today, you've got lots of opportunities to practice. And in lab, you will go over those 6 problems, try to work through them, go over as many of them as possible. The TAs will help you check your work to make sure that you're getting it so that you'll be ready. Do we have any study groups planned for exam 2?
I'm going to post a discussion post about that soon.
Okay, you're going to post a discussion post about that, so we'll have study groups. Lots of practice. Javier has keys for things too, so he has the problem set key, other things, so he can help you if you're struggling with the problem set. He can give you some tips to help you with your problem set. Any other questions about independent or related samples t-test before we start talking about the article? Yes?
I have a quick question. When you do a Cohen field, write them principle, all of that.
Mm-hmm.
Do you want it to write B and R, or?
You'll write one or the other.
One or
I'll
the
tell
other.
you which one I want you
Okay.
to do. So, for example, on the review problems that are posted for lab next week, it actually says for a given problem, for effect size, use Cohen's d.
Okay.
For effect size, use r squared. And I want you to practice, because remember, for independent samples t-test and for related samples t-test, the formulas for those change a little bit depending on which kind of test you're doing. So you want to make sure that you're clear on the right form. So when you do an independent samples t-test, if I ask you to do Cohen's d, you use the right formula. If I ask you to do a related samples test and I ask you to do Cohen's d, the formula is a little bit different, and you want to make sure you know what that is. And work now on making your list over the weekend. The best way to check to see if you're ready for this test would be see if you can make your note card over the weekend. Come into lab on Tuesday with your note card and use only your note card to do the review problems in lab. If you can do it, it means your card has everything on it you need. If you find that there are things you don't have on your note card, you'll know on Tuesday by the end of lab because you won't be able to do all the problems. And that way you can fix your card before Thursday. It's a good way to check and make sure that you got what you need. Okay, so our goal for today is now to practice looking at scientific articles and extracting the kinds of information we've been talking about so that you can get familiar with articles, learn to be able to identify the important parts in whole big long articles rather than little short blurbs like we use in class. And this is practice for our writing unit at the end of the semester, where you're going to be reading articles and writing about them, and you're going to have to extract out these relevant details without me telling you specifically to go get that information. You're going to have to be able to figure out what the independent variables and dependent variables are. You're going to be able to figure out what kind of scales of measurement they're using, where the hypotheses are, evaluate the different types of validity, and I'm not going to walk you through every step. So we're going to practice that now for 3 articles, 1 for each of the next 3 units, this unit and the next 2. So you can get better at doing it with the kinds of techniques, design and statistical techniques, that we're talking about in class. So the article I had you read for today was about people's honesty when talking about their weight, and how accurately they report their weight, and if there are differences between men and women in how they report their weight, and the influence that eating disorder beliefs and social desirability have on whether or not people accurately report their weight. So, very obviously straightforward psychological study, right? People's beliefs about themselves, how they value themselves, what they value about themselves, things like that. So, in the worksheet, you can get your worksheet out. I'm going to go through and just ask the different questions. Hopefully everyone has given this a shot, tried to fill out the worksheet on their own. So chime in with answers, and if we get stuck, I will do my best to clarify. If we get to a tough question, I'll do my best to clarify answers, and we'll see how you did. So, first one says, the first hypothesis tested in this study was that men would be more likely to over-report, but less likely to under-report weight than women. So, what's the IV for this comparison?
Gender.
Gender, okay, of the participants. And it's useful to note that when it's of the participants, because sometimes it could be gender of somebody else. That's the variable. So if it's the gender of the participant or the sex of the participant, put that in the independent variable label. So that's the variable. What are the levels? Male and female, or men and women. Mm-hmm.
Now, when you do a study like this, should you put gender? Because that can be changed.
That's true, but we also, here, they talk about gender. We don't know the gender identity of these people. We don't know the sexual identity of these people. Okay? We know that the people reported, this is their self-report of whether they identify as men or women. So we don't know. They did not do any kind of physical assessment to determine whether the people participating in the study were biologically male or female. So we don't actually know their sex. All we know is their gender, which is what they reported. They came in and said, I'm a guy.
So sex would be wrong.
Many people say that those two things are the same. We're increasingly aware that they're not the same, right? Your sex doesn't mean your gender is totally predictable. So I would accept either sex or gender in that framework, but I think gender is more accurate because there's no assessment of their actual sex. We don't know. But this is what people reported, right? People said they came in and they basically identified themselves as men or women, and that would be gender. That's the right end. But good point. People use sex and gender interchangeably all the time, and they're totally not interchangeable at all. Okay, so is this IV between subjects or within subjects? Between. Why?
It can't be within because you can't switch the gender, so it can't be.
You can't counterbalance gender. You can't say, okay, right now you're going to be a guy, and now we're going to switch and you're going to be a girl. Okay. Or you can't counterbalance that. People come in with their identity. They come in typically, at least the people in the study, come in identifying as one or the other. Not everybody does, but the people in this study were classified as either men or women. You couldn't be in both groups. So it can't be counterbalanced. This is between subjects, right? The people in the men's group are separate people from the people in the women's group. So between subjects. Is this a subject variable or a manipulated variable? Subject variable, right? They come in with their gender identity. We have no idea. We don't get to randomly assign them their gender identity for the purposes of the study. Definitely a subject variable. The greatest challenge for performing a study on independent groups is making sure the groups are similar enough to compare before the experiment begins. We learned a way to do it after we've gathered some data with Fmax last time. We were talking about independent samples. But it's optimally a good idea to design your study and create the samples you're comparing in such a way that they're pretty similar. Tell me how you think they did. Okay.
They were predominantly Caucasian, the same age, 18 to 23, and they all went to the same liberal arts college in northeastern United States.
Yeah, so these are all students at a private liberal arts college in the Northeast on a campus that we can guess is predominantly white. Okay, both of the samples were predominantly white. Chances are these samples pretty accurately reflected the population on the campus. Yeah?
The sample sizes are drastically different.
The sample sizes are super different, though. There's more than twice as many women in the study than men. Why might we be worried about that if we're doing a comparison between subjects?
Data for the men might not be representative.
Less likely to be representative because the sample is smaller, right? What else? What about in statistical terms? Why might we be worried?
Or likely to be skewed by outliers.
Yeah, well, it's more likely that we're going to have better power with the women's sample because since it's more likely to be representative, we're going to have more statistical power. Means that small treatment effects, small Cohen's d, small r squared, are more likely to give us significant results with the women than with the men because the men's sample is half as big. So small effects are more likely to get missed in the men than they are with the women. And that we'll see later on when we talk about statistical validity if we actually think that might have happened in some cases.
So why would the people doing the study of the groups do that different?
Why do you think? That's a good question. Why would they do that?
Might have had more women sign up.
Yeah, talking about convenience sampling, right? Remember convenience sampling? You take who you can get.
You can't just like cap it at a certain, I mean, I guess.
You absolutely could, but if you're worried that the effect sizes are small and that you want to get as big a samples as you can, you might take whoever you can get. There's also an issue in this study where they knew that they're interested in people who over-report and under-report their weight. That means of all the people who volunteer for their study, some proportion are going to have their data excluded because they accurately report their weight. So if you capped both groups at, say, 48, you might run the risk that you get a bunch of people in your sample who actually accurately report their weight. And then the people you got, the samples you're left with, are so small you can't do anything with them. So, I mean, is it optimal to have samples of the same size? Absolutely. But what was this study about again?
Who's more likely to overweight?
Who thinks about their weight? Who might be more likely to volunteer for a study about weight, your feelings about your weight, eating disorders? Men or women?
Women.
Women, right? Especially white women, right? White women, there's a lot of pressure for white women to be very thin, right? And so if you think about who might be willing to volunteer for a study like this, it probably was easier to get more women, so they took who they could get, but it's would it be nice if they had more balanced samples? Absolutely. And so that's something, I mean, we see it right here. They're not hiding it, which is important. They're not trying to pretend they didn't do it. But those are things we're going to have to take into consideration as we read through the study and think about the claims that they make and their evidence. Do we believe them? Especially when we get to the stuff about statistical validity. Because we might not believe some of their findings because the samples are so wacky. Yeah.
Is it also an issue in comparing groups that the women had, I don't know how, it didn't say how many, but the women had at least one subject way on the high side, and the men had one subject at least way on the low side? Is that an issue in groups or just validity?
So they had outliers, right? Chances are that that one individual score isn't going to throw off the data one way or the other. But they have to acknowledge that there are those outliers in society, so you have to decide if you're going to keep them and actually let them be represented in your sample, or if you're going to exclude them. It's just a choice, and I don't know that it necessarily affected the outcome of the study. But good question. Also, you'll notice that the sample of women was more white than the sample of men in terms of proportion. So that's another issue because you're talking about cultural different, the cultural values that different racial and ethnic groups have about body image and weight and size. And so that could have an impact in terms of how people report. The second hypothesis testing this study was that those who underreport weight would have higher BMIs than those who overreport weight. Okay. So who are we? What are we comparing here? What's the ID? What about it though? Not just the report, the accuracy of the report, and we're comparing the underreports and the overreports, right? We're comparing which group is larger, the underreports. And so we're talking about those that underreport and those that overreport. Is that a subject variable or a manipulated variable? Subject variable, right? People come in as underreporters or overreporters. It's not manipulated. I don't get to randomly assign you to the group that says, okay, you're going to underreport your weight. You come in as an underreporter or an overreporter. Okay. And let's think about BMI. What kind of variable is BMI?
Subject.
Well, we don't talk. It's a dependent variable. So I'm asking you: is it what kind of scale is it measured on?
Ratio.
Probably ratio or interval, depending on whether or not you believe you can have zero weight or zero height. But yeah, so it's definitely the kind of dependent variable that would be appropriate to calculate means and standard deviations and that kind of thing on it, right? Good for t-tests, right? Because it's an interval or ratio scale. It has a 0. The units, pounds really mean something. Ounces really mean something. Inches really mean something, right? So if they're measuring people's weight in kilograms and their height in meters or centimeters, those are real units that have 0 values. So we're talking about interval or ratio scale, good, meaningful scales for calculating means and standard deviations. Now, let's compare that to what they did for the subsequent hypotheses. They used not something like BMI, but they used a lot of different surveys. Right? They used the eating disorder examination questionnaire and the eating disorder inventory to look at people's eating disorder symptomology. Right? To look at how many characteristics of someone who's eating disorders the individuals have. Now, what are these instruments measured on? These are Likert scales. Those are those almost interval, super smushy, the numbers aren't real numbers scales. Right? Some of them are 1 to 7. Some of them are 1 to 6. We get later on, they have scales that are measured 1 to 4. Right? So these are cases where the numbers for these other measures are not real numbers. Right? These are really just orders, ordinal values. Right? So all of the analyses that are done for these, they do t-tests on all of these data too. But all of these are done on numbers that technically you can't do means and standard deviations on and have it be real. So these are all of these are really more about kind of associations. Right? These are very squishy numbers, not real numbers. But this is really, really common in social psychological research, where you have to, if you want to find out about people's mental health, you have to ask them questions on smushy scales, like, how positive are you feeling about your life today? What are units of positivity? I don't know, a 6? 6 relative to what? 6 on a scale of 1 to 10, 6 on a scale of 1 to 7, 6 on a scale of 1 to 6. What does the 6 mean in that case? Who knows? Okay. Tell me about the eating disorder examination questionnaire. How many questions did it have on it? 36. And what were the subscales?
Dietary restraint.
Dietary restraint.
Eating concern.
Eating concern.
Shape concern.
Shape concern.
Weight concern.
Weight concern. And then they had an overall score for eating-related problems. Okay? And so lots of different subscales. When we gather data about these kind of phenomena, typically you'll have a longer survey where the questions tap into several related concepts, and then the answers for 4 or 5 or 6 questions get grouped together, and then you get a score for something like eating concerns. Because there might be several questions you could ask that all relate to eating concerns, and then you generate an eating concerns score or a dietary restraint score. So you might ask them, do you ever restrict how much you eat, even, do you ever stop eating even when you're still hungry because you think you're fat? Right? Do you prevent yourself from eating foods with fat? Do you prevent yourself from eating bread? Whatever. So you could ask a bunch of questions that would all contribute to dietary restraint, right? Lots of different things, and then generate a dietary restraint score for that person. What about the eating disorder inventory? How many subscales? Eating disorder inventory. 3. What were they? Drive for thinness, body dissatisfaction, and bulimia. Okay? And different numbers of questions for each one, right? Drive for thinness had 7 questions, body dissatisfaction 10, and bulimia 8. Okay, so here we've got different numbers of questions. That's why, so they're generating a different score for each one of these subscales, and then overall scores for the instrument itself. The fourth hypothesis was that higher social desirability scores would be found among women underreporters and male overreporters. So first we have to figure out what's this construct of social desirability. What is that? What is social desirability?
The tendency to behave or present oneself so as to be viewed in a positive manner by denying flaws or exaggerating positive characteristics.
True. Now what does that mean in regular people's
Impression management.
Impression management, that's right. So you're trying to make a good impression. Right? You're trying to get other people to think you are desirable, right? That you are consistent with social norms, or that you are high on the social goodness scale. You want other people to like you. And their prediction is that higher social desirability scores would be found among women who underreport and males who overreport. So explain that. Why would you think that someone would value social desirability? So care a lot more about what other people think. Okay, this is you care about whether other people like you or not, whether or not they think you're good. Why would that be related to underreporting for women and overreporting for men? Yeah.
Because women want to be viewed as thin or smaller, so they'll underreport because they don't tell you their real weight versus.
Yeah. How many women in here actually have your true weight on your driver's license? Look at you. He moved his hat. I'm like, Javier, why are you raising your hand? Okay, so, but notice that was not a majority of women in the class. I'm not going to ask you whether you overreported or underreported your weight on your driver's license. But women, the expectation, women are supposed to be smaller, right? So women who care about what other people think may underreport their weight. What about men?
They'll overreport their weight.
Why?
Because
So they want to be fat?
no, but I mean they want to be seen as strong and bulky.
Body mass. Yeah. That's right. They want to be buff. They want to have pecs and abs. Right? So they want this body mass, right? Not pure gut, but muscle mass. Right? Working out at the gym. Talking about how much they can bench press. Right? Muscly is good for men, right? So they might over-report if they want other people to think that they're super buff. Right? Not like you can't tell, but I guess they, oh yeah, I got a little bit more muscle mass than you might expect under my baggy t-shirt, right? Okay, so social desirability was assessed using the personality assessment inventory from the positive impression management scale. Can you believe they actually have these things? There's a survey for pretty much everything in psychology. So they went and found a standardized measure for measuring social desirability. So tell me about this measure. Tell me about this instrument. How many questions does it have? 9. Okay. And what are the questions measured on? Another Likert scale. 4 points. Right? 4-point Likert scale. From false, not at all, to very true. Okay. Whatever that means. How can something be true versus very true? Like, hella true. Yeah, what's the difference? It's truer. It's truer than true. Like, what does that even mean, very true? Anyway, that's how it's measured. All right. Now do you see why people sometimes look at psychology and go, soft science? Because you have measures like very true, as opposed to just true. All right. How did the researchers determine if a subject had underreported or overreported his or her weight?
Weight 'em.
They weighed them and you can't tell whether they overreport or underreport unless you let them first report, right? So they came in, they had them tell them lots of stuff about themselves, including their height and their weight. They had them do the whole study, and then at the very end, they weighed them. Why do you think they waited until everything was done before they weighed them to get their actual weight?
They went down.
Okay, so we're trying to keep them naive. Why do we want them to be naive? What do you think? They'll actually report the way they really report. You know, if you walk in, the first thing they do is hop on that scale. And then they hand you a survey and it says, tell me your height and weight. You're like, Like, what am I going to do? Underreport my weight now when I just jumped off the scale? Yes, in the 3 minutes since you handed me the survey, I've lost 20 pounds. You know? So you want people to, you're trying to avoid demand characteristics, other kinds of subject reactivity, right? You're trying to keep the people from focusing on their weight. So you want to get their genuine, like, here's what I would actually tell a stranger my weight is. And then later you find out how on the mark they were. Because sometimes, you know, have you ever been on an airplane and you're talking to somebody on the airplane and you like tell them stuff you would never tell anybody else? You ever told them something wasn't true? There's a whole phenomenon of people getting on airplanes and like taking on different personas, like being people they're not. And like they like pretend they're somebody else on an airplane and get off the airplane and they go back to their regular life. It's very weird. You can just talk on an airplane. People don't know you. They don't know who you are. You can just like pass by. That's where you like moved. You're like, can you please move me because I'm sitting next to a wackadoodle who says he works for, you know, Homeland Security or something. Okay. So it says to evaluate the hypothesis that men would be more likely to overreport, but less likely to underreport weight than women, the researchers performed a series of different t-tests and calculated a variety of descriptive statistics. Lots of statistics. Okay. The first 2 t-tests they performed were related samples, or paired t-tests, comparing self-reported and measured weight for men and women. Okay? Now, we're talking about related samples t-tests now, because we're going to do a test for men and compare their reported weight and actual weight, okay, to see how different those are, reported weight and actual weight. And then we're going to do another test for women, reported weight and actual weight. So the reason these are related groups t-tests is because we're comparing scores for the same group of men for the first test and for the same group of women for the second test. Does that make sense? So when we do this comparison, these are related groups t-tests because we're talking about the same people, 2 different scores for them. Okay? So what was, see if we can find, how would we summarize the result for men? Can we do it using our descriptive strategy that we use in class? Okay, let me hide this for a second. So you're giving me the AP style statement. I'm fine with that. We still want to be able to describe the pattern of results in a sentence too. But let's do that. Go ahead. T42. This is for men. So T42.
-5.84.
Okay.
P less than 0.001.
Okay.
P equals 0.49.
Okay, is that a small, medium, or large effect?
Medium.
It's a medium effect for Cohen's D. Medium-sized effect, 0.49, but very significant. Very significant difference. Okay, all the way to 0.001. So it's very unlikely that this would occur by chance, that difference.
But since it's 4.9, would it be medium, or would you consider it's
Still
just go
small?
ahead and round it up?
So they're reporting it to 2 decimal places. I think medium does break off at 5, right? 5. So you could still say this was even small. And it's kind of weird because this is a small effect, and yet they're getting this amazing significance, right? It's a little bit strange. But that's what they got. So, but it's pushing medium, and we'll see that in this case, in this study, I think we only find 1 or 2 truly large effects, and many of them are kind of on the border, either small to medium or medium to large. But so if you said this was small, I would say that was fine. If you said that D equals 25 and then said it was medium, that would also be fine. But they're doing 2 decimal places, so technically that would still be small. You're right. Okay. Now, what's the one thing we normally report that they don't report? Yeah, they don't indicate whether they did a 1-tailed test or a 2-tailed test. And I don't know. I can't tell. And I would like to know. Because I would think, given that they were predicting a particular direction of the effect, they would have done a 1-tailed test. But because they didn't know for sure, they could have also very easily done a 2-tailed test. I just have no clue. I can't tell. And they don't say, which bugs me. I don't know why they didn't say which kind of test they did. Because it would help me evaluate the statistical validity of their study, and they didn't include it. So it's a little bit weird. What about, but now tell me, what was the pattern of results that this finding represents? we're comparing men's self-reported weight and their measured weight. What was the relationship? Men's self-reported weight was what? Significantly different. What was the direction of the effect?
Over.
Was it? Did they significantly over-report their weight?
You don't know.
Let's take a look. We're looking at the data. Ugh. Okay, so let's see if we can find that stat we were just talking about. Ugh. What is that? Oh, come on, break it for me. Why are you not focusing? This does not help me at all. There's autofocus for me. Okay. So it says, let's see.
Not the little bit. It just says that there's significant discrepancies, but then further down it says that men over-reported and women under-reported.
So to address our hypothesis, that men would exhibit greater over-reporting, paired t-tests compared indicate significant discrepancies. There was a significant difference. Okay, over versus under-reporting. But if you look at the proportion of men who under-reported, what proportion is that? As expected, results indicated that after excluding those with incomplete data, 67% of men engaged in under-reporting, whereas 75% of women engaged in under-reporting. So if we look at this, if we say that 67% of men under-reported their weight, what is this telling us? That is a significant difference for under-reporting or over-reporting? It just means that there were significant differences, right? So that we know that, but we see this negative number here, and it makes me think that their self-reported scores were significantly lower on average than their actual scores. And that's consistent with the fact that 67% of the men under-reported. So on average, the men are saying they weigh less than they actually do. And it's a significant difference between what they really say and what's true. For women, that's also the case. They significantly under-report. Okay. So their report, you can see here the samples. Now you're looking at these two things, and you can see how different the samples are, right? Degrees of freedom, 42 for men, 99 for women. Okay. Because the sample sizes are so different. And if we look at the effect sizes, for men, it's that small, almost medium effect. For women, it's a clear medium effect. So we're seeing differences in effect sizes for men and women, although both, we see negative scores in both cases, and when they talk about self-reported and measured weights, so significant overall, both men and women are under-reporting more than 60 to 70% of men and women are under-reporting their weight. Right, down here? They're talking about those proportions, the means. A much smaller proportion. So men are under-reporting more than anything else. 67% of them are under-reporting. I see questioning faces.
I'm having trouble translating that percentage into what I can't understand that.
Which part?
So you get the percentage, but what does that tell you with that other?
Okay, so how many men total did they have in the sample? Do you remember? How many men total were there? 48. There were 48 men to begin with. Okay? So they started off with 48 men. Okay? And then it says once they did their analysis and they excluded people with incomplete data. And that may mean that when they filled out the survey online, or when they filled out their demographic information, they didn't answer, right? So they didn't provide any information about their actual weight. They did, so for some reason they couldn't calculate their over-reporting or under-reporting. So maybe, because sometimes people refuse to answer certain questions on a survey, right? You can't make them answer it. So it looks like 9 men and 18 women had incomplete data, so they couldn't even be included. So now that 48 men has dropped by 9. Okay, so now we're down to 39 men, right? Of those 39 men, so we have 39 men. Now, 29 of those men engaged in underreporting. Does that make sense now? 29 of the remaining men underreported their weight, and that's about 67%. 2/3 of the men underreported their weight. Whereas when we talk about the women, okay, so of the 100 and something women that were in the study, how many did we have at the beginning? 104 women in the beginning. Okay, 18 of them didn't provide data enough for them to calculate over-report or under-report. And of those, 75% underreported their weight. Does that make sense? So for the people that they could do the calculation for, the people they could do it for because they had the numbers they needed to do the math, 67% of the men underreported their weight. 75% of the women underreported their weight. Then it gets even more complicated, because then they say, well, but not all underreporting and overreporting is the same. Because, I mean, you think like right now, even if you weighed yourself this morning, if I asked you right now how much you weighed, you might not be 100% accurate, right? Because you might have eaten something since then, right? Or you might have used the restroom since then. So your weight might be slightly different. And they're counting everything from 0.4 pounds off. I mean, that's like a big sandwich, right? Or, you know, a super big gulp. 0.4 pounds, right? That's not even a cup, right? That's like you have a Starbucks pumpkin latte and you're off by 0.4 pounds already.
Really heavy sweater.
A heavy sweater, exactly.
And then like who actually knows their weight down to the 0.4?
Yeah, I mean, how many people weigh? I mean, some people weigh themselves every day and know how much they weigh. They care about that. And other people are like, well, I don't know. My clothes fit.
And then what you're wearing could also throw it off.
Yeah, we don't know about it either, right? So yeah, I mean, it could be big sweater. I mean, it's the Northeast. It could be cold. Maybe they're all wearing big sweaters and scarves. I don't know, big foam fingers. Football. So, but they're measuring everything from 0.4 to 30 pounds. So this is counting as a misreport just like this. But not all underreports are created equal, right? So they're saying, wait a second. There's a margin of error here, right? They're talking about measurement error. There's some reasonable amount of, there's a window that you could think that someone is actually trying to report accurately, but they might be a little bit off from reality. If you're a pound off here or there, you have a pretty reasonable understanding of how much you weigh. If you say you weigh 30 pounds less than you really do, this is pretty clearly an underreport, right? You're pretty clearly trying to be dishonest. Maybe not in a bad way. You're just lying about your own weight, but there's something fundamentally different between being less than half a pound off your real weight and being 30 pounds off your real weight. Right? So then they said, well, let's go in here and let's adjust the scores so that we can account for people who are within 2 pounds of their actual weight. And we're going to throw their data out too, because we're saying they're probably genuinely trying to be accurate. So there's some measurement error, but it's measurement error within the margin of error, so we're going to treat it like they're being accurate. We're going to throw their data out too. So now the samples of people whose data they're actually working with are getting smaller and smaller and smaller, because they're throwing out data of people who they think are accurately reporting their weight, or reporting it close enough to count. So we're going to get down here and they're going to start changing the proportions down there. But let's take a look here. So we've got, we look at men. So we talk about men over-reporting their weight. Okay. So they had 12 men who over-reported their weight. That's about 28%. And they had 21% of women who over-reported their weight. But there's 21 women, okay? 21 women over-reported their weight. 12 men over-reported their weight, but proportionately, it's more a larger part of the men's sample. Yeah.
When you, before the margin of error is calculated, the 67.44 and the 27.91 for the men added together is like 95.35. So does that mean that 4.65 of them did accurately report their weight?
Yeah, so there's going to be people who accurately reported their weight or people whose weight they couldn't calculate. Yeah.
But then after the margin of error is calculated, when you add the two men's percentages together, it equals 100.
Yeah.
So it took out any person who did accurately.
Right, they've dumped out everybody, right, they've taken out everybody, because when they're talking just about underreporters and overreporters, they exclude everyone who accurately reported their weight because they're not in there.
Right.
Yeah.
Okay.
And this is where reading articles gets tricky because they're putting all these, they're like doing all these, they're throwing people's data out and including this data, and these people count and these people don't, and you're like, oh god, this is why nobody wants to read these sections of papers. But this is why we have to make sure we understand what they're doing. Yes, question?
Yeah, okay, so going back to the 67%, is it 67% of that 29 or the 30, of 29 men or the total sample, 39?
So this,
Were they underreported?
so if we think about so there was 39, okay, so I'm thinking, I have to break out my calculator. Who has their calculator? Let's see, if we do. So if we take, so 29 divided by 39 is 74%. So if we do, yeah, it's gotta be, it doesn't work for 48 either, so I have no idea how they're getting that number. It seems like it should be,
They started with 42, right?
oh, 42, okay, let me try that.
But yeah, it started at 48.
Okay, so if we divide by 42, 29 by 42, we get 69%. So there's something weird with the percentages, something funky is going on here.
Okay.
But, go ahead.
Percentage, is it coming from the percentage of men that underreported, that percentage that they got, is it from that 29%? Or is it from the...
So they're saying 29% of the, 29 of the men engaged in underreporting. And it says here, after excluding those with incomplete data, 29 men engaged in underreporting. But I don't know if they're using as the denominator the full sample or the sample after exclusion. It's not clear. So now we look at over-reporting. Okay? So in terms of over-reporting, 28% of men over-reported, 21% of women over-reported. And then they did the weird adjustment down here where they said, okay, but some people might actually be accurately trying to report their weight, so let's adjust everything again. Okay. And what we see is that a greater proportion of men, so if they adjust, now 10 of the men, so 33%, and so 10 of 29, that would be 33%, over-reported their weight, and 20, so 2/3, wait, no, so then we have 53 of the men, 53 of the women, 83% under-reported their weight.
I think the incomplete data part is referring to after the margin of error. Because if you do 29 minus 9 men, then you get 20 men, which is what they report after the margin of error.
Yep.
Same with the women. 18 women was taken out for the margin of error.
Yeah, I think you're right. Okay. So what's the critical point here? The point is that I just want you to look through here and see that they're doing, as all these different numbers are being calculated to contribute to, just to get to this test. Okay? Just to come to that test. So when we say independent samples t-test, then compared men and women in the magnitude of their over-reporting and under-reporting of weight. Okay, so if we now look at we look at men and women and how much they over-report, men and women, how much they under-report. So we're doing independent samples tests now because we're comparing men and women over-reporting, men and women under-reporting. We have to figure out what but now still, the samples are very different sizes, right? We're still talking about really different, and it's not clear that you could do a lot about that because these are all subject variables, right? They're all subject variables. So we don't have control over sample sizes. We can't make people over-report or under-report. So in this kind of study, the samples inherently get out of whack because you're dropping people out, including people. So these data are very noisy. Lots of potential room for error in these findings. So if we take a look now, it says, what proportion of, well, we talked about the proportion of men who underreported, proportion of women who underreported, proportion of men who overreported, proportion of women who overreported. Okay. So now we're trying to figure out if there are significant differences between men and women and the magnitude with which they underreport. What did they find? When they did a t-test, independent samples t-test, on men and women who underreport their weight, was there a significant difference in how much they underreported their weight? No. Men and women underreport their weight to the same degree. There was no difference found in the degree to which men and women underreport their weight. Was that consistent with their predictions? No. How is it inconsistent? Yeah, they thought women would underreport more, and that was not the case. What does that mean? Does it mean that women aren't underreporting as much as they thought? Or does it mean that men are underreporting more than they thought? I think men are underreporting way more than they thought. Because men were underreporting, like 66% of them are underreporting their weight. Holy cow, that means men are now starting to fall into the, oh my gosh, I need to be thinner camp. I'm too big. It's what happens when you start having all those masculine body washes and stuff, right? Men are getting makeup and moisturizer and all their stuff. They figured out they can't get any more money out of women, so now they've got to try and convince men that they have to be thinner and prettier too. Yes?
I don't know if this ends up being a validity question, but the fact that the mean ages of their participants were like 18, 19, and 20, were like right on the edge. First couple of years of college, significant weight gain in most people. Does that have anything? That's, you know.
Well, but there's also the issue of that's also prime mating age. You're talking about, let's be serious, between 18 and 22, one of your big things is looking for potential mates, right? And social desirability is really important. It's a very competitive time. Would you agree? I mean, lots of people are looking for dates and mates. And so social desirability, especially, I mean, think how important it was when you were a freshman that other people like you. Right? High school, freshman, sophomore year. This is a time when people tend to care a lot more about what others think. So they might fudge the truth here and there a little bit to try and seem like they're more desirable mate option. Right?
Especially since it's the early side of the college group.
I mean, they're going up to 22 and 23, but still.
But yeah, the mean ages I think were 19 for women and it was almost 20 for the men.
Yeah. But still, this is a time when social desirability is probably also very high. So you're going to get people maybe engaging in some really conflicting behavior. I mean, think of all the strange things you did when you were 19.
I didn't do anything strange.
Never? You were pure as the driven snow.
Right.
Okay.
I certainly had no idea how much I weighed. That went up and down.
Yeah, who knows? All right. So if we look at, so there's no significant difference in underreporting, okay? But among those who overreported, what did they find? Men overreported more than women. So that hypothesis was supported. Okay? So men are over-reporting more than women do, but there's no difference in the amount to which men and women under-report. Yes?
So for the first two t-tests, when they performed related samples, the 5A, you know, what if you kind of like, you know, read down there and you said, like, you summed up that, but then you use those statistics instead of the ones after the margin of error, or should you use the ones that they first give you?
Well, they're required to report both. And I'll tell you what happened. Probably you see this kind of multiple reporting of statistics when they did a primary analysis and they submitted what they thought was a good analysis, and then somebody, a peer reviewer, came back and said, you need to check something. I'm not convinced. You didn't take into account margin of error. I want you to rerun the numbers with all the people who were within 2 pounds taken out, because I'm not convinced. So they have to include all of the numbers. So if you report these, you know, if you report these numbers, you have to be really explicit about the fact of all the people whose data was removed. And that's why they're spending so much time talking about it, because they want people to understand where these t-tests are coming from and what scores are going into it, who's actually getting counted, because it's just a fraction of the people. I mean, if they're including, in terms of like, looking at over-reporters for men, you're talking 10 guys. 10 is not a big sample, but it's a third of the people they've got to work with, and only 10. 10 is a tiny, tiny sample. So they need to know why did they get all the way down to 10, and they have to be able to justify that. Most of the time, that would just not be a big enough sample to do much with in a published paper. Does that answer your question? Okay, so the data for over-reporters was as they predicted. The data for under-reporters was not. Now, here's a kind of functionally different question. For this, for the hypotheses related to over and under reporting as they connect to BMI scores, eating disorder symptomology, and social desirability, were all reported, the statistics weren't reported in that APA style, lay it all out in a line format. Instead, they were summarized here in a table. Why do you think they chose to do that? It's a lot easier to see what's going on here than it is to hack through those paragraphs with all the text, isn't it? And look at all the t-tests they ran. There's a bunch of them. A bunch of them. And so it's easy to organize this way. We just put the measures over here. So here, dependent variable, dependent variable, dependent variable, dependent variable, dependent variable, right? Just putting the variables out there. Then do women here, men here. So here you're talking about levels of the IV. You're talking about all the different dependent variables here. And then you're talking about other comparisons when they've got other variables like over-reporting and under-reporting. Right? So this data, because they ran so many tests that were similar, lends itself to being summarized in a table. Yeah?
The reason they put the first set in text, is it because it's more important, or because they needed to explain why they ran consequent tests and threw out data?
I think they had to explain everything up front, and that first hypothesis was trying to set up the proportion of over-reporters and under-reporters in each group, and they need to be really clear because now they're taking for granted you know who goes in all these categories. But they wanted to make sure that that was very clear up front. And now, I mean, all these comparisons are over-reporting, under-reporting, over-reporting, under-reporting, over-reporting. So they've explained that clearly up front in text. And now all they have to do is they can show you this, and because you understand what these different things mean, you can extract the information you need very quickly. Do you guys know what the dots mean here? It's connected to the alpha and whether or not it was statistically significant. 2 dots typically refers to 0.01. 1 dot refers to 0.05. And 3 dots refers to 0.001. So if you're looking at a table and some particular observed value is marked with asterisks, that's what they're telling you is it's significant.
What about the no asterisk?
there's no asterisk means it was not significant. And sometimes you'll see no asterisk, or sometimes they will put NS for not significant.
So what alpha level do they use for those?
So given that they are probably running these data in a statistical program, they probably set their alpha, I mean, they can say 0.05, but they, if it came out lower, because it will actually tell them what the probability was. If they said, oh, well, let's just see how what the significance actually is, they'll just report as small as they possibly can. So since these tests came out significant to 0.001, they want you to know that. Because 0.05 is nice, but they're saying these are really, I mean, the probability was really small that these aren't real results. So they probably they probably set it at 0.05, and then if they got a better value, they reported the better value, so you had a sense of it. Now, take a look, so you know mean, standard deviation, T, this means T observed. Okay, that's always T observed. What's that one? Cohen's D, okay? So now we have a sense of the effect size. Let's look at these effect sizes. So here we have significance to 0.01 with an effect size of 0.76. Is that small, medium, or large? It's really close. Large cuts off at 8.8. Remember, that's what we were talking about before? So it's pretty close to being a large effect. 0.75, again, medium, but on the large end. What about this one? 0.18. Small. That's a small effect. 0.69, medium. 0.63, medium. 0.30, small. The only large effect we see up here is right here. 1.28. This is very small, small, medium, small, small. Okay? But you can look at this table and very quickly get a sense of how big the effect sizes were, what was statistically significant, what the probabilities were, and it's easier to do the comparisons in this visual summary than it would be if you laid everything out in the text. Yeah.
So for like the 0.69 effect size over there, even though it's a medium effect size, it wasn't statistically significant enough?
Exactly. This concerns me. Okay? Because I want you to look right across the table over to the women. Okay? Exact same measure. Exact same effect size. It was significant to 0.01. So you've got medium, substantively medium-sized effects, right? 0.69. But because of the discrepancies in sample size, for women we're getting a significant result, and for the men we're getting no significance at all. And yet this is a medium-sized effect. So sample size is causing us problems here. And this is a problem with statistical validity. Here we've got a medium-sized effect, and I'm getting statistical significance. I believe that. That's completely reasonable. But here I've got a medium-sized effect, and it's not significant at all. I'm concerned that that represents a type 2 error, that they failed to find a significant difference because their samples were too small. Their sample for men was too small.
Or did they not just saying that it is statistically significant, but only for 0.05, not for...
No, 0.05 would have one asterisk. With no asterisk, they're saying it's not significant at all. If you look over here on the legend on the side, it indicates that 0.05 would be marked with a single asterisk.
Right.
So for here, for the men, they found no significant difference. And yet, it's a medium effect size. The only time I would think that would make any sense is if your sample is too small to find the effect. So in both of these cases, here we've got a medium effect size, and here we've got a small effect size. But here, we get no significance. Here we get no significance, where effects of similar size over here for women give us significant results. Those are the two cases where I think they missed something because of their small sample size on men. I'm worried about that. I think that they failed to find eating disorder symptomology among the men because their sample was too small. And if you look at the extent to which the men underreported their weight, These men are worried about their weight. And eating disorder behavior is increasing in the male population, especially college male population. Someone pointed out in the previous class that the waist size for mannequins in stores for men's mannequins have gone down 4 inches in the past decade. So men are being encouraged to get thinner and thinner, have smaller and smaller waists, and bigger chests. Sounds like women, right? Just for different reasons. Okay? So, something's going on here with the men's sample that I think is questionable. Something weird is happening. Okay, so if we think about, we said they predicted that subjects who underreported their body weight would have higher BMIs than those who overreported their body weight. Was this supported by the data? Okay. That people, so here's BMI as a measure, okay. And we look at men and women who underreport would have significantly higher BMIs than women who overreport. Men would have higher BMIs if they underreport than if they overreport. And if you look, it's significant for both. Okay, so for both men and women, those with higher BMIs, and some people have BMIs, look at this, 48.86. Obese is 25. So you've got people 48.86. You're talking about someone here, they've got people in this range who are morbidly obese. Like their weight is threatening their life. Okay, in terms of BMI. But for both men and women, underreporters had significantly higher BMIs than overreporters. For eating this is for social desirability. Okay, they only got significant differences for women. Only underreporters, so underreporters for women had significantly higher social desirability scores than overreporters. Do you see that? Underreporters had significantly higher scores than overreporters. And significant, we know that, and we know that the effect size was median. For men, no difference. The mean scores for over and under reporters for social desirability, they don't care. They're not over and under reporting because they care about what other people think. Yeah.
Why is the results, does it say where the weight under reporters exhibited lower scores on these scales than over reporters?
Where?
It's right like above the chart in that last, right here, right there.
Here?
That's where they're talking about the
Differences.
sensitivity.
Let's see. So results indicate that differences in weight reporting based on BMI were similar among men and women. Both underreporting men, that's here, and overreporting, both underreporting men and women exhibited higher BMI. So that's this.
Yeah, the next one.
Okay. And then, however, differences based on drive for thinness, body dissatisfaction, and bulimia, they exhibited lower scores. So which one of those is that? Here? Is that the EDIBD? This one?
I
Here,
thought the group together that was the eating disorder symptomology though.
all of them, but I'm not sure if they average the scores together, because here underreporters have a lower score, here underreporters have a lower score. So and because the women's sample is larger, it's skewing the results. Does that make sense? Now, why am I asking you to look at this crazy table? Because on the test, I would expect you to be able, if I gave you this table, and I asked you, for example, okay, looking at the dependent variable of BMI, describe the pattern of results for women comparing overreporters and underreporters. Could you do it? Looking at this table? Looking at BMI. And if I asked you to describe the pattern of results for women, could you do it? Think about our 4-point strategy. When comparing women, those who underreport their weight have significantly higher BMI scores than those who overreport their weight. That's what you should be able to do looking at a table like this. You should be able to tell